Wow, you sure have come a long way. Congratulations on making it through the case study, in which you had to apply skills from both of these Data Science Toolbox courses. You have just used your new skills of writing user-defined functions, iterators, list comprehensions, and generators to explore and extract results from the World Bank World Development Indicators dataset. These are all tools that you'll utilize time and time again in your work as a data scientist, and you have worked hard to earn your Pythonista stripes. Good work, and keep on coding in Pythonland. Now that you're getting a bit more comfortable with comprehensions, we're going to check out generators, which are related to comprehensions in a way that will soon become evident. Recall that this list comprehension will create a list of the first 10 even numbers. Now let's replace the square brackets with round parentheses and voila! Something called a generator object has been created. Now the question on everybody's lips is, what is this generator object? Well, a generator is like a list comprehension, except it does not store the list in memory. It does not construct the list, but is an object we can iterate over to produce elements of the list as required. Here we can see that looping over a generator expression produces the elements of the analogous list. We can also pass a generator to the function list to create the list. Moreover, like any other iterator, we can pass a generator to the function next in order to iterate through its elements. For the geeks like me, this is an example of something called lazy evaluation, whereby the evaluation of the expression is delayed until its value is needed. This can help a great deal when working with extremely large sequences, as you don't want to store the entire list in memory, which is what comprehensions would do. You want to generate elements of the sequence on the fly. Let's say that we wanted to iterate over a very large sequence of numbers, such as the integers from 0 up to 10 to the power of 1,000,000, or at least wanted to do so until another condition was satisfied. Look what happens when I tried to build such an iterable list using a comprehension on DataCamp servers. My colleagues disconnect me because the list I'm trying to create can't even be stored in memory. Be warned though, do not try this at home, on our servers or yours. Check this out, however. I can easily create the analogous generator object because it does not yet create the entire list. What's really cool is that anything we can do in a list comprehension, such as filtering and applying conditionals, we can also do in a generator expression, such as you see here. You'll get a whole bunch of practice with this in the upcoming exercises. The last thing to discuss before you get coding is the ability to write generator functions. Generator functions are functions that, when called, produce generator objects. Generator functions are written with the syntax of any other user-defined function. However, instead of returning values using the keyword return, they yield sequences of values using the keyword yield. Here, I have defined a generator function that, whenever called with a number n, produces a generator object that generates integers 0 through n. We can see within the function definition that I is initialized to 0, and that the first time the generator object is called, it yields I equal to 0. It then adds 1 to I, and will then yield 1 on the next iteration, and so on. The while loop is true until I is equal to n, and then the generator ceases to yield values. This generator function can be called as you do any other function. Here I call the generator function with the argument 5. We see that it produces a generator object, and that we can iterate over this generator object with a for loop to print the values it yields. Generator functions are a powerful and customizable way to create generators. You'll have much practice with these in the coming exercises. Happy generating, friend.